Wait for it, wait for it. Wait for it. And you are live. Take it away, Niels.
Great, thanks, Lauren. Hi, everyone. My name is Niels, recent Atlanta transplant, as I just said. I'm currently in transition to a new position, so I have 2 weeks off to just play around. And so what I'll present to you today is just one of the new things to come out of the Python world. So I don't know if this is fairly recent, so I'm not sure if everyone's familiar with this, but in PEP 622, there was a proposal that was recently accepted for pattern matching, which I'm very excited about. I know this is like, Python has recently gone through many, or a couple of feature iterations like the walrus operator and this one that are like cause of some controversy, but I am personally excited about this new feature. I think it'll come out in 3.10, which is still in beta. But really quickly, just to show you this repo by Guido van Rossum, it's called Patma. It's like a tutorial page basically with some examples of the new pattern matching feature. And there's also this binder link that I have open on my own fork of the repo. But yeah, I'll spend maybe 5 to 10 minutes like explaining why I'm very excited about this. So I'll skip this part first and kind of try to motivate why pattern matching is exciting. So if we have this function, if we have a function, let's just call it a elif function, and it takes an argument. And you might have done something like this. This is like a trivial example, but you might have like if and elif statements to execute different bits of logic depending on some kind of expression. And so here I'm just saying, depending on the value of x, I want to return different values. And this is how it's been in Python for the longest time, and it's, you know, it works pretty well, and it still works in most cases. So with the pattern matching syntax, this is again a trivial example, so it won't immediately be obvious what the benefits of this are. But if you've programmed in other languages that have case statements, switch case statements, this looks kind of on the surface to be very similar, but actually I'll get into why this is very powerful. And pattern matching is nothing new. It's implemented in other languages like Haskell and like OCaml and a bunch of others. So let me just finish this up. So these are basically equivalent, right? So if we call elif function on one, let's see. Oh no, something happened. Let me reload this binder. Okay, good. Oh man, I just lost all of that work. Okay, well, good thing is I have a notebook that I kind of did this in before, so I just wanted to try the whole live coding thing just to build up certain ideas, but let me just copy paste from now on. Okay, so what I did here was I just looped through a bunch of data, evaluating these functions on that data, the elif literals and elif the match literals. And you can see they're outputting the same stuff. So basically what's happening here, this match statement is evaluating this expression. So this could actually be some other expression like x.split if this was a string or something like that. But right now it's just the x variable that's being fed in as the argument. And it's looking at, it's comparing that value with these literals 1, 2, and 3. And this underscore is sort of the catch-all default case. So it's equivalent to this else. So this looks fine, right? This is quite like semantically, it's quite similar to the if-elif, the if-elif pattern. But let me show you this code snippet. So this match sequence function takes an argument x. And here you're seeing something a little bit different. You're seeing the first case is also literal. So it's a tuple of two elements, both of which are 0. And it's going to print 2 zeros. Now, the rest of the patterns here might look familiar to you with the variable unpacking. So I can say something like this in regular Python. And then AB, you expect AB to be those two values that are in these two elements. So I can do something like this also. So 1, 2, 3, 4. And I can say, use this syntax to assign rest to the rest of the elements in that list. So A is assigned to 1, and then the rest is assigned to 2, 3, 4 in that list. So a similar thing is happening here in this case statement where for a sequence of two values, I'm going to actually bind those values to the variables A and B. So that this captures the case of a two-elemented a sequence with two elements. The third case is a sequence of 3 elements. And then this fourth case captures the value of the first element in A, or the 0th element in A, and then the rest of them in a list in this rest variable. So if I just evaluate all of these functions, by the way, so this is also, I think, syntax in 3.8 or 3.9, where you can print out like A equals the value of it without having to say A equals A like that. So those are equivalent. But the cool thing here is now I can evaluate different types of data that are going in. And actually, it's not just with sequences. I can do mappings, so dictionaries. So with dictionaries, I can capture cases of like, say I'm processing data that's coming in from like some API call or something, and it's returning different kinds of like JSON formats. The first one of which could be like an object or a dictionary with a user ID, first name and last name field. So here in that case, I'm binding these variables to the values in the key value pairs of that dictionary. So in this case, it's a dictionary with a user ID field and a key field, and I'm also capturing any other arbitrary sets of key value pairs with this KW-args thing. There's a bit of syntax here that I kind of mixed in, and this is not like the most, I would say, pedagogically sound example, because yeah, there are a lot of different concepts here. But let me just run this so I can kind of walk through what's happening. So in the first example, this is the first case, right? So this is a dictionary with user ID, first name, last name. This just has key, user ID and key. So this second entry is executing this part. So this is just any mapping for this third case. And then the last case, this could be anything, but here I'm just raising a value error that it's not a valid value for this match mappings function. And so then lastly, it's not just sequences and mappings, but I could actually also evaluate different types. So if you've ever done something like if is instance, I mean, I know this is like, by some standards, not like the most Pythonic way of doing things, but if you've ever done something like this, do something, and then you do like some other types, like so on and so forth. This is a perfect use case for the match case, where here I'll just execute this just so we can see. So if the input is an integer, then you add 1 to the number. If it's a float, you double it. And if it's a string, and here, this is another piece of a syntax. You can bind the values that go into the types, and you can also condition on that value being, following some kind of logic. So I only execute this code block down here if it's a string that's not equal to foo. So if you can see, this last call to the match types function is foo, and it goes down to this default branch of the match case statement. And then the last thing is, I'll end with this, is the types can be nested, like arbitrarily. So here, I'm taking in 2 values, x, y, and then this is an expression that is the subject of the match, pattern matching. And I can do different things depending on the types of x, y. And in this case, I'm adding 2 integers, I'm adding 2 strings. So here it's like foo1, since I'm turning this integer into a string. And then if I can use this pipe, that operator to indicate either floats or ints, or yeah. So this is I think this is really cool. I will use this, I guess, when 3.10 comes out. But there are considerations about backwards compatibility and stuff. But I am excited that moving forward, Python will have this kind of syntax available, since it makes, like, writing this logic in isInstance or has attribute or something would be kind of cumbersome. So yeah, that's all I wanted to share. Thank you.
Great, thanks so much. Would anyone like to ask Niels a question while we are still live streaming?
When does that go live?
June. Yeah, early June, I think. Yeah, if you look up PEP 622, there's like a estimated release date, or in the Python website. I'm not exactly sure, but I think, yeah, it's like June 3rd or something. There are some like gotchas, but they're kind of also related to just Python's overall gotchas. So like if you have, yeah, anyway, so if you have a variable like defined elsewhere in this, in the like global scope or local scope of the function, and then you have it as a case. So if you have like foo equals x or foo equals 1, and then you have foo as a variable in the case, it'll override whatever value you used. So there's just some certain things to be aware of when using the feature.
Any additional questions?
So could you just quickly summarize what can be matched and what cannot be matched using this pattern matching?
Yeah, so so quick summary. I'm still kind of learning.
Oh, sure.
But yeah, literals, like for sure literals, it's basically equality. Sequences that have the same syntax as kind of like the variable unpacking that we're all used to in Python. Mappings and types.
Mappings meaning what?
So like dictionaries. So let me just go back here. Right, so in this case, we're basically pattern matching this type of dictionary with the input, and then capturing certain variables inside that dictionary to do some, these are just print statements, but you can imagine like useful work from using these. So yeah, you can also bind like entire things. So this entire dictionary would be bound to this variable. So things like that.
Ooh, okay.
So mappings.
Pretty complex.
Yeah, so I like, yeah, in my first kind of tech job, the engineering team used OCaml. So I sort of learned OCaml as this, pure functional language, and they use pattern matching over else if, like generally, like I think it had else if statements as well, but I think pattern matching was um, more dominant as a use case. So yeah, it takes a little bit of kind of just like looking and reading these kinds of statements, but once you're used to it, it's like super powerful in terms of
I mean, it's basically
make,
functional programming. So in functional programming languages, this exists, this type of pattern matching, or pattern matching in general. It's much more popular.
Yeah, so the one, I guess since I'm here, the one gotcha. So for example, I have this match gotcha function, and then I'm declaring this variable, variable equals bagels. And you would sort of expect, naively, the case variable would check whether x is equal to variable, which is bagels. But actually, if you execute this, what happens is, so if I give it pizza, the variable is bound to pizza. And so if I print variable after this match statement, it's pizza, no longer bagels. So that's like one of the things. I think there are a few other gotchas with this new syntax, but I think overall it's super useful. I mean, mainly, I think for me, yeah, I use a lot of isInstance or has attribute to check for types, and I think this kind of thing would make my code a lot more concise and just like capturing different cases expressed as these types of case statements.
Yeah, this is very cool.
Okay, great. I see that we have an additional sign up on the sign up sheet. Does that person want to be live streamed?
So what is this live streaming?
We're on YouTube right now.
Oh, we are on YouTube?
We're on YouTube.
Well, I don't know. This will be my first time to talk about deep learning, so I don't know whether I should be live streamed.
I think if you're willing to share, like it's obviously no pressure, but if you're willing to share, I think you'd be surprised that, beginners often learn best from other beginners, right?
Okay.
If it's your first time speaking, I think you can bring something really valuable to the conversation.
Okay.
But honestly, no pressure. This is
whatever, yeah.
You want to try it out? We'll try it
the
out.
words don't come so easily, certainly if you try something first. Yeah, no, I can try, yeah.
Let's try it. Let's try
Or
it.
should I be the next one, or?
Yeah, so you're the next speaker. Tell me how to say your name. Is it Ferenc?
Ferenc.
Ferenc?
Yeah.
All right, great. It's really important to me that I get everyone's name right. So let me go ahead and spotlight you for everyone. And yeah, take it away.
So I should share my screen, right?
Yep, if you have something to share, go ahead and hit the green button.
Okay.
I can see it.
Can you see it?
I can. Yep, take it away.
Yeah. Okay. So my original aim was to compare a simple, fully connected convolutional network to fully connected neural network to convolutional neural networks. Okay, I got to the point that I coded up the fully connected neural network. So this is the typical or first example that you code up and you start learning about neural networks. It's about classifying images of individual digits, what you can see in the upper right corner. So these are 28 by 28 pixel handwritten images of digits. And this is the so-called MNIST data set. Can you see my cursor too, or yes? Okay. Okay, so it was Jan LeCun who did a lot of work on this particular data set, who actually assembled the data set. He's now a professor at NYU and Facebook's chief machine learning officer or whatever. So he was looking at 5 different neural network structures. So he was applying neural networks to 16 by 16 pixel images. And these are kind of strange symbols, but what this symbolizes here is that he has a matrix multiplication. So he just flattens this 16 by 16 image and converts it into a one-layer neural network, which has only just 10 neurons. And those 10 neurons correspond to the 10 possible outcomes. So the digits go from 0 to 9. So on each neuron in the output tells you what the probability of that particular digit outcome is. Okay, and then, so this is just multiplying by one matrix. So this is a 0 hidden layer, so there are no hidden layers here. And in this second try, he had this one hidden layer or in-between layer. So he has 2 matrix multiplications, one from the image to this layer of 12 neurons, and then another matrix multiplications to get the multiplication to get the 10 neuron output. And then he, so LeCun is famous for coming up with a completely new structure, which is the so-called convolutional neural net, which works in a markedly different way from these simple so-called feed-forward fully connected neural network. So anyway, what his result was that with the simpler structure, he was able to reach 80% accuracy. So out of 100 images, he was able to get 80% of them right, or 80 of them right. So he misclassified 20 of the images on average. And then with the second structure, he was able to capture like 86 or 88%. So the error rate was like 12%. And then with the convolutional structures, more and more complex convolutional structures, the error rate went down from this 20% to 5%, and then 1%, and even below 1%. But anyway, okay, so this was a long historical introduction. But the idea of neural networks is the following. So you have an input layer, and then you have an output layer, and you have hidden layers in between. And then you just have these 5 neurons. Those are 5 numbers, and you apply a matrix. You multiply them by a matrix, and then you get an output of, let's say, 10 neurons or 10 numbers. So you have a matrix of 10 by 5. So you get on the hidden layers, you get 10 numbers. And then you multiply this layer or these 10 numbers by another matrix, 10 by 10 matrix in this case, and you get another set of neurons in the next hidden layer. And then you apply another matrix, and then you get another hidden layer, and then eventually you apply a final matrix, and you get the output layer. And in addition to these linear transformations, you have nonlinearities. in a neural network. So on each neuron in the hidden layers, you apply some sort of nonlinearity. Typically, what you apply these days is the so-called ReLU, rectified linear unit, which is just which simply means that if the number that shows up on a particular neuron, if it is positive, then you just leave it as it is. If it is negative, then you zero it out. Okay, so there is a linear transformation, the matrix transformation, and there's a nonlinear transformation on each neurons, this ReLU activation. Okay, and then okay, so a next ingredient is that on the output, you know, so you have labeled data, so you know what the output should be. And then you compare that known output to the output that you get from this transformation using your matrices. Now, the entries in these matrices are not known. That's what you want to determine. And the way you determine it is that you compare on the output the actual ground truth, the actual labels, with the outcome that you get by letting the information flowing through the network. So let's say you have an image of 5 pixels here, and then you apply these matrices and the ReLU, and you get an output, and you compare that output to the ground truth. So you get a number on the output. And then, so this is the forward pass, and there's a backward pass, which is called back propagation. Using that backward pass, you calculate how much you should change the entries in these matrices. These entries are also called weights sometimes. But anyway, what you usually see on the output is a convex function which has a minimum. And you want to determine this minimum, and where this minimum is, that's where your optimal weights are. Okay, so so you have these W weights from all of the matrices. Let's call these together theta. And J is this so-called loss function. And then you want to determine the minimum of this J, of this loss function, with respect to the theta. So with respect to all the entries in all the matrices. Okay, so, and this way you want to determine eventually the weights themselves. Okay, so, and then I coded this up in PyTorch. So here I'm loading just plotting and libraries and NumPy, and then I load various Torch libraries, classes, and functions, and the data set itself, which is this MNIST data set. And then I put, I'm going to put the data to a GPU. So I create a device, and then I'm going to transfer all the matrices and the model to a GPU. Okay, so this MNIST data set has a training set, separate training set and test set. So 6,000 images in the training set and 10,000 images in the test set. So as I said, the images are 28 by 28 pixel images, and each pixel is between 0 and 1. So just a number between 0 and 1. Okay, here I'm defining train and test data loaders. So I just load the data, and I'm going to load the data in such a way that I'm going to load them in batches. So in the training case, the batch size is 64. So I'm going to load 64 images in one pass. We're going to see what this one pass is later on. And in the test case, I load 1,000 images per pass. Okay. So as I said, we have these matrices and we have the images. So the images are 28 by 28, and they have only one color, and the batch size is 64. Okay, and here I load a few images just to see what they look like and what the associated ground truth or label is. So this is the training set, and this is the test set. So you can see that, for example, this is a 7, and it is labeled as a 7 by a human being, but this is a 0, but this could be a 6, but this is labeled as 0. Or for example, this one, where it's labeled as 5, well, it could be almost anything. It could be an 8, or it could be a 6. Now, if I look at the histogram of an image, okay, I said that each pixel is between 0 and 1. Here I transformed the images a little bit in such a way that the mean is 0 and the standard deviation is 1, because it is you get better results if you would do this kind of transformation. This is called whitening of the data. So every image is whitened this way, that the mean is 0 and the standard deviation is 1. Okay. So here I'm going to define the network itself. So the input is going to be 28 times 28. As I said, it's going to be flattened. So the input is going to be flattened. The hidden layers are going to have 11 neurons, and the output is going to be 10 neurons, because there are 10 classes. Okay, so in this class, I'm defining the model, so the neural network itself. In PyTorch, you need to define a forward function or method. And in the forward method, I do exactly this flattening. So X is an image, and I transform. So it comes in a 64 images come in a matrix, or actually a tensor. So the first dimension is the batch size. So that's going to be just 64, and I'm going to flatten out the rest of the image. So I'm going to, instead of 28 by 28, I'm going to have 784 sized tensor here. Okay, so it's going to be 64 by 784 tensor or matrix, tensor. Okay. And then this is going to be the input to the neural network, which, as I said, is just just 2 matrix multiplication and 2 values. Okay, so here this linear layer is just a matrix multiplication from input size to hidden size. From what was it? From the 784 to 11 neurons, and then I apply the value on these 11 neurons, and then there is another linear transformation, matrix transformation from 11 neurons to another 11 neurons. Then I apply again a nonlinearity, a ReLU nonlinearity, and then I apply another matrix to transform from these 11 neurons to the 10 neurons as the output. So on the output, I'm going to have 10 numbers, which is the score. So it's a number between -infinity and infinity, and I'm going to choose that number that is the largest, because that has the largest probability to be the actual correct outcome. Okay, so if the ground truth is, let's say, a 5, then I want the 5th neuron to have the largest score output here after this linear transformation. Okay, and then yeah. Okay, and then there is a so-called, okay, there's another transformation at the end where I measure the loss function, and the loss function is the so-called cross entropy, which transforms these scores, these numbers from -infinity to infinity into the 0, 1 range. So this way on each neuron, each output neuron, a number shows up between 0 and 1, and if you add them up, they just add up to 1. So you can consider these numbers to be probabilities. So you can consider these numbers that give you the probability of getting an output of 5, for example, if that neuron, the fifth neuron, has the highest probability, which also corresponds to the highest score outcome. Okay, and then here I define two functions for training, one for training and another one for testing. Let's see how they work. So I defined a model, which is this neural network. So I input the data, which is 64 images. I get the output. And on the output, I apply the loss function, which is the cross entropy, which is this probability distribution across the output, 10 output neurons. Then once I have that, I calculate the gradient of the loss function with respect to the weights. So the entries in the matrices. And then in the next step, using the optimizer, I make one step in the weight space to get closer to the minimum of the loss function. And then I iterate. I do it many times, and I try to get as close to the minimum of the loss function as possible to get the optimum weights. Okay, so that's what I am doing here. I am running 4 epochs, and I'm measuring on the test set the error rate. So after the first epoch, it's 11%, and the second 9%, then 9%, and then the fourth epoch I get down to 7%. So the error rate that I can get after 4 iterations is 7%. So it means that that out of 100 images, I misclassify 7. Okay, so this is the result. So I just picked 15 images here, the ones that I had before. So for example, if you look at this one that I talked about earlier, so the ground truth, the human label is 5 on this image, but the network classifies it as 6. Okay, and all the other images are classified correctly. Okay, so that's it.
Awesome, thank you so much. This was actually a really complete tutorial. Are you going to upload the notebook anywhere, maybe to your GitHub or something like that you could share?
Sure. Yeah, I actually want to create the second part. So I really want to do the convolutional neural net part. And then, so this is in Colab, Google Colab. I'm going to post it somewhere that people can actually look at.
Amazing. Thank you so much. I'd like to open it up for some quick questions. We do have one more speaker signed up for the live stream, and then we've got I imagine a 5-minute, usually the last one goes pretty short. That won't be live streamed, but any quick questions?
What made you pick this data set to work with? in this type of model?
This data set, well, this is perhaps the simplest. So when people start learning, deep learning, I think this is the first data set, this MNIST data set that they first look at. Oops. So there was no particular reason. I just picked one.
Gotcha.
Yeah, it's certainly one of the classics for image recognition.
Yes.
There's also an MNIST fashion
Yeah,
data
I
set.
thought that maybe I should do that, but I don't know.
Yeah. We had someone present on it. Gosh, now I'm dating myself. Maybe like almost 3 years ago. We did a workshop using that one. But yeah, it's another really cool image processing data set.
Mm-hmm. But there are several others. There's a CIFAR 10 or KIFAR 10 maybe. That's another famous data set, but there are several others. So some of them contain only 10 classes, but there is another one from Google, I think, that contains like 1,000 classes. What's the name of that? I have to look it up. Yeah.
Yeah, if you end up finding those, go ahead and drop them in the chat. Yeah.
Okay.
Fantastic. Charles, are you ready?
Yep, I'm ready.
Friends, I think you need to stop sharing your screen.
Okay, sure. I did so.
Oh, I wasn't talking, so I've gone ahead and spotlighted you, Charles, and I think as soon as you share, you can take it away.
All right, so I wanted to talk about a fun project that I completed recently. So I found out about this newish library called AI TextGen. That's a simple wrapper around GPT-2. So I thought this was pretty exciting because I had been following the developments in deep learning from afar, running nothing myself. So this seemed like an easy way to get into it. So if we look at their Hello World tutorial, so we could just run something like this. So just 3 lines of code, and so we can just run this hello unicorn. So 3 lines of code, import and generate, and this will use GPT-2 to generate sentences starting with this prompt. So it takes a little while. So what I did with this library is I was thinking about how I could use this, and I decided that I was going to create a Twitter bot. So actually, let's just skip waiting for this. It's taking a little longer than I thought. Oh, there we go. Yeah, so it's it generated sentences with the prompt, I like unicorns because. And they start off pretty good, but they kind of devolve into nonsense. So what I ended up doing this was I decided I was going to create a Donald Trump Twitter bot. So it's been going for a couple days. Some of the responses are pretty good. Some of them are pretty so-so. So you can scroll through and see what the bot has to say. True to style, my account was suspended yesterday for an inappropriate tweet. So
this is doing what exactly?
So this bot is taking Biden's tweets as input and generating a response. And my goal was to do so in the first-person voice of Donald Trump.
It's taking actual posts.
Yeah. So every time there's a new tweet, then it generates and posts a new response.
And it's actually doing it?
Yeah, it's actually doing it.
Uh-huh.
So you can see that it's like coherent English, but it's not always responding. It's usually somewhat on topic, and English is coherent, but it's a little bit off. But I thought it was pretty funny. It was easy to put together.
So this is running as a scheduled GitHub action that runs every 10 minutes. So every 10 minutes, it checks for a new tweet. If it finds one, then it generates a response and it tweets. Workflow disabled because my account is suspended. So the code itself is actually just, it's pretty small. So there's just a workflow, and then this is the main body. So I'm not going to go through everything, but there's the two things I wanted to point out were the magic formula. So instead of worrying about Google Colab or fine tuning or a small model or big model, this library just lets you feed in an input and then get an output. So I actually found that this magic formula of taking 3 hard-coded previous tweets and then wrapping it in Trump, and then ending it with I, and then wrapping that with the prompt, so that the prompt is a new tweet. So this magic formulation gives pretty reasonable results without fine-tuning. So this is the magic sauce. And then the second thing I wanted to point out was that I actually asked for 60 responses because lots of the responses are repetitive or bad. So I asked for 60, then I have this crazy scoring mechanism where I score it and then pick one that looks reasonable. And that's
what
it.
What do you mean by reasonable, or how do you check if it is reasonable?
So lots of hard-coded metrics, like it's not too short, it's not too long. There's no, some responses include links that don't exist or to previous things that aren't related. So there are no links, no retweets, no symbols, no ban words. So ban words like Hitler or kill, like no, none of that. Some tweets are the same thing repeated twice. That's no good. I don't want anything that's too similar to the input. So sometimes it will just regurgitate the input. I don't want that. I don't want anything that's too similar to the hard-coded input tweet. So just ruling out all the bad stuff I saw, and it works okay.
Mm-hmm.
That's it.
That's awesome. I think it's a really creative use of the GitHub Actions, Charles.
Oh yeah, it's an abuse of GitHub Actions. Actually, so you can tell it to run every 5 minutes, but it doesn't actually. It only runs when it's free. I raised an issue saying, hey, you're not running my job every 5 minutes, and this is a known problem.
Okay, great. Any questions for Charles? Thanks so much for sharing this with us.
What's API are you using to communicate with Twitter, and why were you banned? Is that just because you have Trump in the name, or is there another reason?
So I'm using Tweepy. It seemed like the most popular one. It was pretty easy to use. I was banned for posting a tweet on violence. So my most recent tweet, I have to go to the top. Yeah, maybe I was banned for posting a tweet about violence, and it's kind of talking about the opposite of violence. So I can see why I got suspended for it. But you can go check it out yourself. It seems like not a good idea to talk about the exact wording. I'll post it in the chat once I stop sharing. I can find the chat.
Yeah, I think the chat will show up when you stop sharing.
Okay.
I just dropped a package, not a package, a GitHub page into the chat. Darius is a bot maker, and he has this package called Word Filter that I've used before to avoid banned words. So I don't know what you were doing for your banned word filter, but I think it's especially important when you have these automations out in the world that they don't totally misrepresent your own beliefs. They're like children, right? Like you gotta You got to parent your bots for sure.
Yep.
Well, awesome. Thank you so much for sharing this with us.
Why are you doing this? Or what's the, I mean, besides that it's fashionable, what's the actual reason to do this?
Because it was fast and easy. I started going through some deep learning stuff and training and setting up Colab, and it's a lot. You have to know math, you have to know some DevOps to get your machine running, and it was just more than I wanted to do. So when I heard about this library that's just plug and play, I thought that's really cool, and I wanted to do something with it.
But then what could it be used for? So I see many people setting up bots these days, but they are producing, I don't know what.
Producing laughs.
Producing what?
Laughs.
Labs?
Laughs and happiness. I think this is pretty funny.
The bot or what? Or what? So what's... So I don't really see the, so I've never seen an actual application that, you know.
Well, so I felt like this is a little moot after learning about GPT-3 and how super amazing that is. And it seems like you don't need to do any fine-tuning at all because it is just so great. But yeah, there's whole companies just based on.
So when you say that it's great, what do you mean by that?
Like the output is very accurate. The output is what you expect.
What do you mean by that?
Like it's just very natural, right?
It's natural.
It's quite difficult to distinguish between a human language and the bot language, except like you said, sometimes the bot kind of goes off the rails, right? Especially if you sentences in.
Mm-hmm. But why do you want to create such a thing? So I don't really see the reason somehow. So beyond practicing, I don't really see, or I haven't seen a bot that actually did something.
I think just practicing, that's the main reason. I needed something to practice on, and I had to pick something.
I see. Okay.
Awesome.
I mean, you could collect data from various sources and you could summarize some things. I would see some actual, you know, reason to use a bot. But, you know, just, so this is basically random posting, right? That's my understanding. So it doesn't really go beyond that. So just a random number generator, but it's not producing a random number, it's just producing a random language or output, right? Words and sentences.
Well, not quite random. So the input to the output is the tweet. So it usually is on response. For example, this one is talking about first town hall, and the response is talking about jobs. And this is like related because town halls usually talk about jobs. So it is usually on topic.
So you mean the answer is kind of related to the input. So the output is related to the input. That's what you're saying? That
yeah, right.
It's
So if we wanted to get started playing with this on our own, Charles,
yeah, so
that you had, or could we go to your GitHub page?
You could clone it. I wrote some instructions on what you'll need to do if you wanted to run this yourself.
Amazing. And so then I hate to cut us short, but we're almost at the top of the hour and we have just one more talk, but I'm going to turn off the live stream now. Thank you to all of our speakers tonight.